Have you ever just looked around at a tree or the stars or even yourself and wondered, how did all this happen? I mean, we're told the universe is constantly moving towards chaos, right? So how on earth does it manage to create such incredible, breathtaking order? That's what we're digging into. All right, so let's get right to the heart of this puzzle. It's this massive contradiction that's been bugging scientists forever. The basic rules of physics, they kind of scream chaos and disorder. But then you open your eyes and what do you see? Structure, complexity, beautiful, intricate patterns everywhere. So here it is, the big question. If everything is supposed to break down, to fall apart into just a random mess, then how do we exist? How do galaxies and stars and planets and, well, life itself even get off the ground? It just doesn't seem to add up, does it? Just look at this. On one hand, you've got pure chaos. Think of it like random heat, just a formless jumble. But then, on the other hand, look at that. Something with mind-blowing structure and order. And the crazy part? They both exist in the same universe. That's the paradox we need to crack. Okay, so there's a sciencey name for this whole tendency towards chaos thing. It's called entropy. And the rule that governs it, the second law of thermodynamics, is, well, it's a bit of a downer. It basically says that in the long run, chaos always wins. Everything winds down, everything falls apart. And that single relentless rule is what makes something like a galaxy or even your own brain such a profound and beautiful mystery. So to figure this out, we've got to put on our detective hats. And our investigation is going to start somewhere you might not expect. Not in a physics lab, but in the pure abstract world of mathematics. This is where we find our very first clue. And here's what's so wild about this clue. It turns out you don't need some super complicated blueprint to build something incredibly complex. No, all you need is one simple rule. A rule that you just repeat over and over and over again. And the amazing things that pop out, they're called fractals. I mean, just look at this. It looks like a whole universe of detail, right? But its origin story is so simple, it's almost funny. This entire unbelievably intricate structure comes from just one little math equation, just looped on repeat. And what's so crazy is how, well, how natural this feels. It looks organic. These patterns, these swirls, they look like something you'd find in nature, something almost alive. But they're not. It's pure math, all born from that exact same idea. One simple rule repeated forever. And it's the same story here. You can see these patterns repeating themselves, right? Little versions of the big shape tucked away inside. It's this beautiful cascade of order, and it all comes from one tiny logical starting point. Here's another one that'll blow your mind. The rule for this one is dead simple. You just take a straight line and you replace it with a specific shape made of 8 smaller lines. That's it. You do that again to those new lines and again, and before you know it, boom, you get this incredible branching object with loops of all different sizes. And this points to a really cool property called self-similarity. It means that if you could zoom in on any tiny little piece of a fractal, it would look pretty much identical to the whole thing. It's like a pattern within a pattern forever. And that is a massive hit. Maybe the universe itself uses simple, repeatable rules to build all the complexity we see. Okay, so that's clue number one. Math shows us that simple rules can lead to incredible complexity. Pretty cool, right? But for our next clue, we're going to leave the clean, abstract world of math behind and jump right into the messy, chaotic, and very real world of biology. Think about it. If entropy is this constant pressure, this universal force pulling everything apart, then life is the ultimate rebellion. Life is the great resistance. I mean, every single living thing from a tiny bacterium all the way up to a giant blue whale is this unbelievably complex little machine that is in a constant active fight against falling apart. So how does it pull this off? Well, through evolution. And evolution is really like a dance, a two-step between chaos and order. Step one is chaos, random mutations. These are just chance screw-ups in the genetic code, pure randomness. But then comes step two, the ordering part. It's called purifying selection. The environment basically acts like a bouncer at a club. It's a ruthless filter that kicks out the mutations that don't work and lets the good ones stick around. I love this analogy. It just clicks. Think of the letters of the alphabet. A, B, C, D, they're like the raw material, the random genetic mutations. Now, if you just threw them on a page randomly, you'd never get Shakespeare, right? It's the process of choosing, of selecting which letters go where that creates the masterpiece. And it's the exact same with life. Selection is the author, filtering all that genetic chaos to write the incredible story of life. All right, so we've got math giving us simple rules, and we've got biology giving us a powerful filter. But this kind of raises an even deeper question, doesn't it? We know how to describe the complexity, and we know how life sifts through it, but what's the actual physical process? How does order pop up from just raw energy and matter to begin with? For that, we need our third and final clue. And this clue comes from a Nobel Prize winner, a guy named Ilya Prigogine. In his discovery, it was a total game changer. He found that if you get the conditions just right, chaos doesn't just make more chaos. Sometimes it does the exact opposite. It can actually spontaneously give birth to order. He had a name for these things, dissipative structures. And the perfect everyday example is a whirlpool. You know, when you pull the plug in a bathtub, that swirling vortex. That's an ordered pattern. It's a structure. But it only exists because there's a constant flow of chaotic water moving through it. It literally feeds on that chaos to maintain its own order. Wild, right? And it seems like life itself might be a kind of dissipative structure. So how does this actually happen? Well, it's kind of a four-step process. First, you flood a system with a constant flow of energy, pushing it way out of its comfort zone. Second, that energy flow creates these powerful feedback loops. Then, and this is the magic moment, you hit a tipping point. Scientists call it a bifurcation. At that point, tiny little random jitters that are always there suddenly get amplified. They get huge. And fourth, the whole system has no choice but to reorganize itself spontaneously into a completely new, more complex, ordered state. And you can literally see this happening right here. These incredible patterns are called viscous fingers. They happen all on their own when you push a thin fluid, like air, into a thicker one, like glycerin. There's no instruction manual, no blueprint telling it to make a tree shape. It's a dissipative structure. This is order literally emerging from the chaos of energy flowing through a system. Okay, so we've collected our clues. We've got one from math, one from biology, and one from physics. Now it's time to put all the pieces together and finally see the big picture. So what have we found? First, simple rules, when you repeat them, can create infinite complexity. Think fractals. Second, filtering mechanisms, like natural selection, can sift through randomness to build and preserve order. And third, a steady flow of energy can push a chaotic system to organize itself into something new and more complex. And all of this leads to this one final, absolutely stunning comparison. Look at this. On the left, that's a pattern made by a simple computer program. On the right, that's a pattern from a real-world physical process. I mean, the resemblance is just uncanny. It's like we've caught the universe red-handed, using the exact same playbook to create order, whether it's with pure math or with actual physical stuff. So, when you think about it, the story of the universe isn't really about inevitable decay. It's a story of incredible creative potential. Yeah, entropy is a law, sure, but it's clearly not the only rule in the game. It seems the universe has this hidden code, this built-in knack for finding new and amazing ways to build order from chaos. And that leaves us with one final mind-bending question to chew on.